So, did you know the most expensive bug in your AI agent might be its lack of memory? When your agent starts conversation from scratch every single time, you're not just frustrating your users, but you're also paying more for your agent to learn the same facts again and again. And today, we're going to fix that. We'll use Google's Agent Development Kit and Vertex AI Memory Bank to show you the complete playbook of building agents that can also remember. And this makes your agents smarter and less expensive to run over time. In the next 20-ish minutes, we'll walk through the different memory services in ADK, how memory generation, consolidation, and retrieval works, and how do you use memory in your agents, and finally, we'll show you how to customize which memory should be persisted and set up a TTL. And by the end of this video, you will know all the strategies to build agents that are smarter and less expensive to run. Today's guest is Kimberly Milam, who's also the tech lead for Vertex AI Memory Bank. But before we invite a special guest, let's do a super quick crash course on core memory concepts. I promise you it won't be boring. So, what is memory in relation to agents? Basically, it's the ability to store and retrieve information from conversations across sessions. Think of it like this: your agent has a short term memory for the current chat and a long term memory for everything else. The short term memory is also called volatile memory. It's quick, it's easy, but once the conversation is over, it's gone. Great for when you're just messing around with development. But for the real world, you need persistent memory. This is like the agent's long term knowledge base, the stuff that sticks around. And with Google's Agent Development Kit, you've got options. For short term memory, ADK gives you the in memory memory service, and for the long term memory, you can go the managed route via Vertex AI Memory Bank, use other third party solutions, or create your own custom database. Which brings us to the question: how do you actually store and retrieve memory from your agents? I have a 4 step workflow for it. Step 1: initialize your memory service. And step 2: add your session data to your memory service. The session holds all the information for the current conversation, including the prompts, the agent's communication between another, and the state. And the memory service then decides which information to persist from the session and consolidates this raw data. And step 3: make your memory service accessible to your agent. And step 4: use a ADK built in tool like the preload memory tool to auto fetch memories, or use the search memory API to retrieve the context as needed. All right, enough talk. Let's get our hands dirty with code. Off to you, Kimberly.
Awesome. So let's get started with memory and AI agents with ADK. So with this tutorial, we're going to cover the ADK InMemoryMemory service and the Vertex AI Memory service. Memory services are essentially ADK's way of orchestrating calls to underlying memory storage systems like Engine Memory Bank to read and write memories. Then we're going to cover generating memories using both InMemoryMemory service and the Vertex AI Memory Bank. Then we're going to cover retrieving. And then lastly, we're going to cover how to customize a memory bank to your own business needs. So this could be customizing what information memory bank extracts from your conversation and also setting the TTL for any of your memories. So let's get started. So first, I'm going to set my project and my location, which are required by ADK, so that it knows where to send any model requests. Now let's get started and actually use memory in our ADK agent. First, we're going to start by defining our ADK agent. And for this example, we're just going to use a simple conversational agent where we're just instructing it to answer the user's questions. I'm not defining any tools here, but you could always plug in your own tools into the agent so that ADK can orchestrate all those calls to the tools for you. Then we're going to define a session service. In this case, I'm using the in-memory session service. And so for this session service, all of your events only persist as long as you're using your computer. As soon as you restart your computer or maybe make a request to a different VM, all of those events are lost. So we don't recommend this for production use cases. If you're using this in production, we recommend using a persistent database like Agent Engine sessions. Then we're using a runner that orchestrates the calls to your agent and to your session service. You'll notice I'm not defining a memory service here. And although we'll do this later on, we want to at first orchestrate the calls to the memory service manually so that we can compare the different offerings that ADK has. So now let's define our memory services. So all ADK memory services are based off the base memory service. And the base memory service essentially identifies a common interface that ADK can use to generate and retrieve memories. So let's look at GitHub to actually see the source code for base memory service. So you'll see there's two key methods. The first is add session to memory, which takes your session, does some sort of logic to extract information from it, and then persists it in whatever underlying database you're using. Then we have search memory, which searches over that corpus of data to actually find memories that are relevant to your app, user ID, and query. And the actual business logic depends on which sessions or which memory service you're using. So the logic for memory bank, for instance, may differ from the logic of using an in-memory option. So first, let's cover what in-memory service does. So to define it, we don't have to actually provide anything because there's really no setup. It's just on your computer, similar to the in-memory session service. And looking at the underlying source code, all of your data is actually just stored in a dictionary. So it's stored on your computer, your VM, and it's keyed by the app name and the user ID, and it saves all of that raw conversation events. So it saves that turn-by-turn conversation, not actually extracting any information or using LLMs under the hood to extract information from the content. For search memory, it uses the query to see overlap in the words that you use. So for instance, if you use the word bicycle in your search query and in the memories that you're storing in in-memory memory service, it's likely that those memories will be coming up. But again, these memories are pretty verbose. They're pretty identical to the turn-by-turn conversation that you store in your session. So now let's move on to defining the Vertex AI Memory Bank service. So this is a layer on top of Engine Memory Bank. And if we go and look at the source code in GitHub for the memory bank service, it again uses those similar methods, add session to memory and search memory. And so for add session to memory, it's actually making HTTP calls to memory bank. So it's a asynchronous non-blocking call. So this means that memory generation happens in the background. So just because you make a call to memory bank to generate memories doesn't mean that memories have yet been generated or that memories will be generated. The processing is actually happening in the background so that you as the client are not waiting for the response. And the information that's sent to memory bank is, again, that turn-by-turn conversation. But even though we're sending that turn-by-turn conversation to memory bank will extract information from that conversation and won't persist everything. We're also using the scope to identify the isolation key for our memories. So scope essentially acts as a key for the memories. So memories will be consolidated for other memories that have the same scope, and you'll also retrieve memories for the same scope. So when you're interacting directly with memory bank outside of ADK, it's very important to have the same scope as what ADK uses. Otherwise, you might not be able to find the information because information is isolated for that specific scope. The other key method is search memory, which takes that app name and user ID to again build that scope key. And then it uses the query that is of the current user turn to retrieve memories using similarity search. Then it takes the response from memory bank and packages it in a object that ADK uses, in this case, search memory response. So this actually means that the information that you retrieve from memory bank might not necessarily map, or it might not exactly be the same as the information that you see in search memory response, there may be more information in the response for memory bank than there is in the ADK response. So a lot of times, if you want more transparency into what's happening under the hood, I recommend using the Agent Engine SDK directly so that you can see everything rather than just what ADK shows you. So let's go back to our notebook so we can actually define our memory bank. To get started with Memory Bank, you need to first create an agent engine. And an agent engine is kind of like an umbrella over multiple Vertex agent products, including Memory Bank. So to get started with Memory Bank, you need to first create an agent engine. And here I'm using my own GCP project. But if you don't have a GCP project, you can actually get started with Vertex in Express mode, which only requires an API key. So you don't need a project, you just need a Gmail to get started. Here, I'm defining a configuration for my memory bank, although you can always use the default configuration that Memory Bank provides. And here, I'm just using Gemini 2.5 Flash, and I'm using that model because I want to make sure that my memory bank is good at following instructions, because there's a lot of instructions that happen under the hood to use memories and to instruct the LLM to actually extract memories that are meaningful for my conversation. So let's actually run this. And this just takes a couple of seconds to run. The actual longer part of this execution is the definition of a client, but the agent engines create just takes, I think, like 1 or 2 seconds to get started. And that's it. I'm already set up with Memory Bank, so I can actually use it in my agent now. Before I move on, Sita, do you have any questions about getting started with Memory Bank?
Not exactly a question, but to summarize what we've just seen so far, I think we've discussed what base memory service is in ADK and how there are two different types of services, which is the in-memory service and then the Vertex AI Memory Bank service, which extends the base memory with these two APIs to provide their own flavors of memories, right?
Yes, exactly. So they both interact with ADK in a consistent way, but the actual logic under the hood completely is different between the two services. So that's actually a great segue to digging into the logic to compare what information is persisted within memory service versus memory bank. So let's start by defining some simple sessions. And sessions, again, are the source content from which we extract data. So first, I'm going to do a chit chat session. It doesn't really have that much meaningful information. I'm just asking my agent to define what types of questions do you answer. And this is information that's probably not meaningful across multiple turns or multiple sessions. So if you just want to persist with meaningful information, you probably don't want to persist this. And you can see it's just describing the types of questions that your agent and the LLM can answer. It's quite verbose. I really don't want all of these tokens to be persisted in future conversations because that gets very expensive as the number of tokens adds up and just isn't information I need to persist. Then let's define another session. So this one has information in it, although not all of it that is meaningful. There is a lot of information in here that is meaningful. So, for instance, I'm telling it I have a 3-year-old niece. I'm telling the agent that I like the idea of a bike for a present, and it's information that, although isn't directly um, like content that I might need in the future, there's elements of it that is meaningful to persist. That being said, again, the response that I'm getting from the LLM is very verbose, lots of tokens. Probably don't want those tokens in future sessions because that token usage adds up quickly. But overall, me and the agent decided that for a 3-year-old, a balance bike is a great option. So let's see what information is persisted by the two different memory services. So for the in-memory memory service, I'm going to peek at that dictionary that was saved. And you can see it saved all of that like very verbose information. So all the information is keyed by my app name and user ID. And then it stores that turn by turn information, all of it, including both the user turns and the agent conversations. And this might be hard to action on. It's hard to use this in future conversations. It also includes a lot of extraneous information where if I'm doing full text search over this, there might be a lot of false positives. But let's actually test that out. It's very verbose, so lots of scrolling to do. But let's actually test that out to see what information is returned. So I'm going to do the classic query and see what is returned when I say test. And I guess the word test was never used in my turns, so no memories are returned. But then let's try what should I get my mom for Mother's Day? And it returned all of that turn by turn conversation that, again, very verbose, lots of tokens to be used, and may not necessarily be actionable. And now, before I move on to memory service, Sita, do you have any questions about the memory service?
No, I think this was a great demonstration, Kimberly. So, what we've seen right now is you've created two different sessions, but with completely different questions and different outputs. And both are very verbose. So, we've tested this so far with in memory memory service, which actually persisted all of these verbose information and did not do any consolidation. So, our token usage is high and everything is high. And when we ask a query to the in memory service, this did not even return anything that was useful, but like looks for a conversation that's already in the memory and then returns it. Is that right?
Exactly. So it's really that raw information. It's not condensed or any way. And actually, if I asked the same information over again in a session and uploaded those new turns in the into memory, that information would then be duplicated so that not only would I have that original high token usage, I'd have it again in future interactions and in future memories.
Yeah, I think with that said, we still have to like give a little bit of props to the in-memory service because that is actually great for development. Like when you're building out something new, when you're just testing it out, I think it's a nice little tool to use. And then when you're actually maturing your service or they're moving into prod, then you can like seriously consider about like adding a memory layer into it.
Yeah, I think that in-memory memory service is good when you want a proof of concept to basically be like, hey, is memory useful for this type of conversation? But I think as you're talking about production and talking about like higher quality memories, you do want to use a managed offering because there's a lot of complexities that go under the hood with memory generation and retrieval. And that's actually a great segue to talking about how Memory Bank works with ADK. So, with memory generation, there's two key methods that happen under the hood. They're automated by Generate Memories. The first is memory extraction, where we extract memories from the conversation, and only information that matches the memory bank definition of what is meaningful will be extracted from that conversation. And let's say that our definition of meaningful isn't per se what your definition as a developers is for meaningful information. And for that, we offer customization, which I'll cover later on, where you basically define the definition of meaningful, and the memory bank will extract information that hits your topics. Second is consolidation, which takes that new information extracted from your conversation and sees if there's duplicative or contradictory or even complementary information in your corpus that should be combined with those new memories. So this makes sure that you don't have duplicative information. It also just kind of self curates your memories over time so that they could evolve based off of the new information or the new environment around. So it's kind of like agentic memory, where not only is it a record of information, but it's curating itself as well. So let's actually move on and use it. So one key thing to call out here is that memory generation happens in the background. So by default, ADK will will return a response immediately. And this doesn't mean that memory generation has completed. It also doesn't mean that memories will be extracted. Again, memories are only extracted if the information is meaningful. So I'm going to run this as soon as I get a response, and you'll see that the response is empty. And that's because memories are generated in the background. So I still need to wait a few seconds for memories to actually be extracted, consolidated, and added to my corpus. The reason that this is a non-blocking function is that memory generation under the hood requires multiple LLM calls to be chained together. This could be relatively latency intensive, and you don't want your client to be waiting for memories to be generated because generally memories aren't useful until the next turn. You don't need them for the current turn unless you want to give users like dialogue to tell them, hey, we extracted memories from your conversation. That being said, if you do want memory generation to be blocking, you can use the Engine SDK directly and just tell it that you want to wait for completion and that it will be a blocking function. But again, with ADK, the default behavior is that it's not non-blocking. So let's rerun this. So now you can actually see the memories that were extracted from that conversation. It is not the turn-by-turn conversation, unlike the InMemoryMemory service. It just extracted the ideas of, I like the idea of getting a bike as a birthday present for my niece, and then also the information that I have a 3-year-old niece. So that was information that was kind of like hidden in my content. The other thing that you'll notice is that that chit chat conversation didn't actually result in any memories because there wasn't information that was meaningful for future interactions. Sita.
So, Kimberly, you showed the difference between the in-memory memory service and the Vertex AI Memory Bank, and really want to call out the point of the difference in the token length is actually staggering. What would you say is like the average difference in the token output that you normally see when using Vertex AI Memory Bank and switching from other solutions?
Well, it really depends on your source content. If you remember, we had that chit chat conversation versus the recommendations conversation. And for the chit chat conversation, nothing was extracted, whereas the recommendations conversation, 2 memories were extracted. So it ultimately depends on how meaningful the information that you're sharing is, and also whether you've already collected that information. So whether information's being newly added to memory bank or existing information is being updated. So a lot depends on like the shape of your conversation. But again, the in-memory memory service does no filtering. It does no extraction of information. So it's just the raw dialogue. So it's very verbose, whereas memory bank will kind of like only include the information that's new and that is meaningful.
So, makes sense.
Mhm. So again, if you want to interact directly with Memory Bank, I recommend using the Engine SDK, which gives you a bit more control over what information is sent to Memory Bank and some of the configurations. So with if we go back to that GitHub source code, you'll see that with retrieve memories, which is this function right here, I'm using similarity search. But this is actually optional. You don't always have to use similarity search to retrieve memories. So if you don't provide similarity search parameters, it will just retrieve all of your memories. And again, I'm using that same scope that ADK used when defining your memories. So the app name and user ID, and that's the key for your information. And let's say that I forget to use app name, you'll see that no memories are returned because memories are isolated by an exact match of their scope. And if I don't have an exact match, I can't retrieve memories. And if you want to use similarity search, similar to what the ADK memory service uses, you can just provide your search parameter in your request, and then it'll give you the distance in the method, and it'll sort by the distance between your query and the fact that's stored in your memory. So Memory Bank again has 2 processes under the hood. The first is extraction, where it just extracts that fact from the conversation, kind of throws out all the other material. The other is consolidation, where it takes that new information and combines it with existing information that you might have in Memory Bank. So I have this information. I like the idea of getting my niece a bike for her 3rd birthday. And in this case, I actually want, let's say I upload that same duplicated information again to Memory Bank. I don't want to have multiple memories that cover the same topic because that's hard to action on in reality. So if I upload this new information, you'll see that my existing memory was actually updated. So it, rather than adding a new piece of data to my memory bank, it just updated the existing memory that I have. But what if you want to use memory as a tool where your agent is responsible for extracting memories? And for that, you can use generate memories, but provide a special type of input that we call direct memory source. And this is essentially a pre extracted facts where you already extracted the facts from the conversation and you're just uploading them to memory bank and expecting memory bank to consolidate it with the existing information that you have. So it allows you to access the different parts of memory bank in a modularized manner. So again, you'll see that that memory was updated rather than adding that new duplicated information to memory bank. But how do you actually get your ADK agent to generate memories? So the runner itself does not automate the action of saving session to memory. To do that, you either have to call save session to memory or generate memories directly. But what if you kind of do want to automate it more? You could use callbacks to basically say at the end of each agent interaction, I want to call this function that adds my session to memory. And this is actually based off of a great blog post from one of our DevRel engineers, Megan O'Keefe, essentially providing a callback that has access to the context, that full turn-by-turn conversation, and adding it to memory. And the agent will automatically call it under the hood without me automating anything. One key thing to call out is before you'll see in these prior interactions with the session service. Sorry for all of the scrolling, but at the end of the session, I'm actually refreshing my session object. And that's because the session itself is not updated with that turn by turn conversation. I need to refresh it or there will be no content to send memory bank. So if I'm calling add session to memory directly, I need to make sure to refresh my session object first. But in this case, I'm automating with callbacks. So I have access already to the invocation context, which includes that already populated session. And so now let's actually use our callback. And for this, I would expect it to print triggered memory generation every time that the callback is requested. And you can see here between each turn, it's triggering memory generation. So memory generation is happening in the background. Let's see what memories were actually returned. And it's actually that similar. I got my niece a red bike for her third birthday. And the prior example used that entire session, but what if you just want to use the latest turn? And for that, you could actually use memory generation directly with the Engine SDK and just access that user content from the callback context. And they'll just use that last turn of the conversation. So this could be a bit, it ensures that you're not sending duplicative information because if you're sending that full session, you're sending it every turn of the session. You could be setting the same turn over and over. The downside with this, however, is that you might be losing some content from prior turns in the session if you're only sending the current turn's information. So now that we've created our memories using memory generation, let's actually use them in our agent. And to use memories, you basically have to dynamically construct the content that's sent to your agent, whether that's the turn by turn conversation in the context or the system instructions. And ADK offers two built in tools to automate retrieving memories and adding it to your context. The first is the ADK preload memory tool. And the ADK preload memory tool, although it's called a tool, it's more like a callback, I would say, because it is not invoked by the model. The model does not decide to use the preload memory tool. It just always runs before the agent is actually executed. So it's kind of run right here if we look at this diagram of how ADK interacts. And we're also going to use a callback to print the system instructions so that you can see what information is sent to the model. So if we look at the system instructions, you can see that they now dynamically include that information that we generated in prior interactions in the system instructions. So it includes information of my niece recently turned 3 years old, and I plan to get her a doll for Christmas. So now when I ask my agent, can you remind me what I got my niece for her birthday? I guess I should ask her for Christmas, not for her birthday. So let's actually change our prompt a little. And it should have access to this information that I sent before. And it reminds me that I was planning on getting my niece a doll for Christmas. So it now has access to all that information that I've stored and persisted. And because it's a new session, it's not reading that information from the conversation history, it's just reading it from memory. The load memory tool is similar. It's also managed by ADK and orchestrated by your runner. The big difference is that the model needs to decide that loading memory is necessary. So I'm going to ask it, what should I get? What I got my niece for Christmas. And you can see in the system instructions, it's telling the agent that they have memory and that information can be looked up in memory if they need it. And then you can also see that the agent decided to invoke my tool for memory and ask what I got my niece for Christmas. And the actual response includes the memory. But let's say I have like a simple like hi, and memory is not helpful for this hi. And so you'll see here that the tool was never invoked because your agent decided that memory was not useful. You can also use a custom callback to retrieve memories if you want more control. So let's say that you want to use your own scope keys, or you want to kind of like customize how the information is formatted in your prompt. So you can define your own callback to directly call memory bank and to directly format the content and add it to your system instructions. So we are going to say hi. And since we're using a different scope than the ADK memory service, we don't have access to those prior memories because if you go back here, I'm only using the user ID for my scope, but ADK by default uses user ID and app name. But let's try it out with our new callback. So first, let's generate memories for our new scope. So we're using that same scope that the callback's using, where it's just the user ID key. You can see it created a new memory. I'm going to ask it, what information do you know about me? And it knows that I have 4 nieces. So it's able to access this new information and retrieve it using a callback so that I can connect memory generation with memory retrieval. And Sita, before I move on to customizing behavior, do you have any questions about memory retrieval?
Yeah, just a quick highlight of what you've explained so far. We've seen two tools for memory retrieval. One is the preload memory tool, which automatically gets called before an agent is called and then adds the memory to the system instructions for the agent to use. And then the other way that provides a little more granularity is using the callbacks, where we can choose where we want the memory to be inserted by using like a before tool callback or an after agent callback, whichever point you pick, and then using the actual memories API service, right?
Exactly. So if you're okay with basically using the default behavior that ADK provides, you can use one of the tools. Um, but again, you kind of have to be okay with the behavior that ADK provides, whether that's a scope or how the information's added to the context or what information sent to memory bank. So if you want to customize, you can always create a callback to automate it yourself.
Sounds good.
So far, we've just been kind of using the default settings for memory bank. But what if I want to customize how memory bank deems information to be meaningful? So by default, memory bank will always persist information that's deemed to be personal information, user preferences, key conversation events and task outcomes, and explicit instructions to remember or forget. And this is what we call managed topics, where Google defines the instructions and the label and the few shot examples of like what matches with this information. But let's say that you only want to use like a subset of these memories, like you only care about user preferences, but don't care about key conversation events and task outcomes. And for that, you can actually customize the behavior of Memory Bank. You can see that took like less than a second to run to actually update my agent engine with my new customization. And I'm specifying the scope ID or scope keys user ID. So this configuration only applies to requests that use exactly the user ID scope. So here you can see that memories that fit user preferences category will be persisted. So persisted information from here, you can see a memory was created, but information that does not fit user preferences won't be persisted. So you can see there's actually an empty response here where no memories are returned. But what if your use case for memory doesn't fit into one of our managed topics? You can also define your own custom topics, where rather than relying on Google to provide your label, description, and few shot examples, you bring your own. So for this example, I'm going to use a topic that you might not even think of using memory for, but it's basically to condense and extract feedback for your business. So maybe you have like a feedback forum where people can provide um, like information and recommendations for your business. But there's a lot of like unmeaningful information or duplicative, and you don't want to do all that data mining yourself to extract only the meaningful information. So you can actually use Memory Bank for this use case. You can create your own custom memory topic to define the label and descriptions. So I'm saying I want to save specific user feedback about their experience at the coffee shop. I'm also providing some few shot examples where I'm providing like a sample conversation here and then the expected outcome for memories that should be extracted from this conversation. I'm also saving an example of a conversation where like the information is not meaningful and shouldn't be persisted. So basically it's like a no op where there should be no outcome for this. So I'm going to update that same agent engine with my new topics. Again, I'm still using the same agent engine from the beginning. I'm just updating it and kind of fine tuning how I want it to extract information. And my expectation would be no information is extracted from here because although I used to want to extract user preferences, I now care more about business feedback. You can see nothing's extracted in this case. But now I'm going to give it the feedback. You should have more milk options. And you can see it created a memory since this fits into the memory topic that I provided. And then you can actually see the memory. So the memory that was persisted is I think that the coffee shop should offer more milk options. So it gives me a condensed record of the feedback that my customers are providing. And let's say I actually provide something slightly similar where like you should have almond milk. That's kind of similar to that last query I sent. And my expectation would be that this combines it with the memory that I already have because it's pretty duplicative information. You can see that rather than creating a new memory, it updated the existing one with I think that the coffee shop should have more milk options such as almond milk. Sita, do you have any questions on customization before I move on?
Yeah, I think this is a nice little trick because you don't always fit into the four predefined labels for memories, right? So having the custom options is like a nice little way to have any kind of information that you want your agent to remember. So, which brings me to the question: like, do we have? Can we set a TTL for these memories? Like, how long should the memories live?
Yeah, so you can set TTL for your memory bank, and you can always set it on like the individual memory. But you can also set it like more programmatically where Memory Bank will set TTL for all of your generated memories. And this is especially important because the memories that you generate aren't explicitly created by you or your agent. That's more agentically managed under the hood where Memory Bank is creating and mutating them. So when you're generating them, you don't have full access to the resource to be able to set the TTL. And so to make this easier, what we allow you to do is essentially define a default TTL when you're setting up your memory bank. And so, for example, this is a 30-day TTL. And then let's just generate some memories for an example. And I'm saying I have 4 nieces. And you can see here that the expiration time is set to September 28th, and that's a month from when we're filming. And so this memory will no longer be available after September 28th. There's actually a lot of operations that can create memories. You're not just always using, you might want to have a different retention based off of what operation created the memory, or maybe you even want to just set the TTL when the memory is created and not refresh the memory when it's updated. And so to enable this more like granular control, you can also define a granular TTL where you define the TTL per operation that created the memory. So for example, I just wanted to find a TTL when I create a memory. When I update that memory, I don't want to refresh the TTL. I just want to start the timer when I actually create it. So you can say, like, remember I work at Google. You'll see here that the TTL for this is 1 year from now on this date. But let's send the same request. And because of consolidation, we expect the same memory to be updated. And you can see here that the TTL hasn't changed between my 2 requests because I use this granular TTL where I define which specific applications should set TTL. And that concludes the information that I have prepared. I'd say the best place to learn more about Memory Bank is the Vertex AI documentation that goes deeply into how memory generation works, how you can configure a memory bank, and then it also provides quick starts for using both the Engine SDK and ADK.
Thank you, Kimberly, for the walkthrough. All right, it's now time for our Eng Talk section. We've scoured the internet and found some burning questions about Memory Bank and ADK, and we'll have Kimberly to answer them. So let's dive in. Kimberly, why should someone not use just databases but instead use Memory Bank?
Yeah, so if you're just using a database, the content that you're storing would be pretty similar to what we saw previously with the InMemoryMemory service, where you're storing that raw turn-by-turn dialogue. So a ton of use tokens, a ton of information that might not be meaningful to persist for a long period of time. When you're using memory services like Memory Bank, you're only saving the information that's meaningful for the future, and you're also using consolidation to basically deduplicate information and curate your information over time. So you really only store what's necessary for the future rather than storing everything. You're also doing that processing at storage time to reduce the information that's meaningful rather than putting more onus at retrieval time to just retrieve what information is helpful.
And if I added my agent's instruction to remember a specific piece of information, does that even make the memory bank remember them?
Well, so there's a difference between what the agent's responsible for versus what memory bank is responsible for. So the agent ultimately is responsible for orchestrating the calls to your different tools and services. So if you have a tool to extract memories and then send it on to memory bank, yes, that instruction would be helpful. But ultimately, like memory bank is responsible for extracting that information. So rather than providing that instruction to your agent, I would provide that as a custom topic so that memory bank knows what type of information to persist.
Can I use memory bank with other models other than Gemini, like Olama or Mistral or anything else?
So memory bank only supports Gemini models. You saw in the beginning of that collab, I actually provided my model name when setting up my memory bank, and you can provide any Gemini model name.
Thank you, Kimberly, for this deep dive walkthrough. And that's about it for today.
Awesome. Thank you so much for having me. And don't forget to use ADK and memory bank.
We've learned how crucial memory is for creating personalized and intelligent AI agents, and we've explored the differences between volatile memory and persistent memory. And we've also seen how memory generation, consolidation, search, and retrieval works with Google's ADK and Vertex AI Memory Bank. And now it's your turn to build your own memory powered agent. Check out the description below for all of the resources and links and let us know what you built. And until next time, happy coding!